In this question, we have given a parabola, 4 minus x squared parabola. It says find the point on the parabola that are closest to the point 0, 2. Okay, this is a fixed point. The question is asking this as minimum, okay, as minimum, the distance must be minimum, and which xy has the minimum distance to this point 0, 2. Here, it's about closest distance, okay? You must use the distance formula. We have 2 points, x1 and 0, 2. We can write the distance as square root of, remember, the square of the difference of the first components, x minus 0 squared plus, and then square root of the difference of the second components, y minus 2 squared. So we must arrange this one. Here, this one will be x squared plus y minus 2 squared. This is the distance between 2 points. But here the problem is this function has 2 variables, x and y. We must use the original function to make it one variable. Y equals 4 minus x squared, right? See, in this question, it is better getting value of x squared. Okay, we can put 4 minus x squared instead of y, and then take the square of that expression, but it will be longer than this option. What is the best option? We can interchange y and x squared, negative x squared. X squared will be equal to 4 minus y. Okay, in this equation, x squared will be equal to 4 minus y. So I'm going to get the function in terms of one variable, but this time the variable will be y. So instead of x squared, I'm replacing 4 minus y. At the same time, I'm expanding these parentheses. Remember, square of the first term, double their product, 2y and double it, 4y, and square of the second term plus 4. So inside the square root, add or combine the like terms. We got only one y squared, and then negative y, negative 4y, negative 5y, and 4 plus 4 is 8. That's it. This is the function, distance function in one variable. In the next step, we are going to differentiate this function with respect to y. And next step here, what's the derivative of this function? S prime is equal to, remember, derivative of the inside, 2y minus 5, all divided by 2 times square root of y squared minus 5y plus 8. And we are looking for a minimum value. We must equalize the derivative to 0. Here, 2y minus 5 will be equal to 0, because here there is 0 over 1, cross multiply, 1 times 2y minus 5 is equal to 0. So y is equal to 5 over 2. See that your answer cannot be D, because 5 over 2 is the second component. In ABC, we have the 5 over 2. But what about the first component? We must plug in this. Okay, we know that x squared equals 4 minus y. Okay, in the above relation here, we got this one, 4 minus y. And here, I'm going to replace the y value here, x squared 4 minus 5 over 2, and x squared is equal to 2 times 4, 8, minus 5, 3 over 2, and x equals, I am taking plus and minus because this parabola has a symmetry with respect to y-axis. We have a symmetrical point on the other side, which has the same distance, okay? We can say this is negative xy according to the chosen variable. And here, x plus minus square root of 3 over 2. We can leave the answer in this way, but I cannot see square root of 3 over 2 in the choices. I must continue a little more. This is root of 3 divided by root of 2. Remember how to rationalize denominator. We must multiply by root of 2 and root of 2. This is plus and minus root of 6 over 2. Okay, what is the answer? Answer is B. Okay.